Julia, stop muting me or
I
give me the
wasn't
co-host power.
muting you. I was asking you to unmute, actually.
Okay,
I think
good.
we were trying to do the same thing at the same time.
Okay. Can I start? I'm ready.
We are
Excited to
alive.
do this. Yay! Welcome everybody. My name is Milan and I'm the bookend manager for the city of Rio. And tonight I'm super excited because after 9 weeks of intense work, our data science students will be showing you their final projects. And for us, it's very exciting because it's our first data science bootcamp in Latin America. And for me as a professional, I did the web dev bootcamp of Lovagon. So when I deal with our web dev bootcamp, I know everything about the bootcamp. But this bootcamp was so different for me. I've learned so much thanks to the students and the teachers and the projects you're going to see tonight. It's something else. Like some of them could be the main concept of some Black Mirror episodes. So please be as excited as me because this is going to be good. First thing first, for the ones who don't know Le Wagon, I just wanted to introduce it quickly to you. So basically, we're the best coding bootcamp in the world, and we're not the ones telling it. Our students are saying it for us. If you go on Switch Up and Course Report, which are a big ranking website of coding and data science bootcamp, you can find that more than close to 2,000 students reviewed us as the best learning experience for coding and data science online. And we're very famous for two programs. The first one is a web dev bootcamp, and the second one is a data science one that you will see the results tonight. And we're very lucky also to offer these bootcamps in two different formats. The first one, if you're a crazy person who has all the time in the world, is to come for 9 weeks, Monday to Friday, 9 a.m. until the evening, to come and code with us all day long. And then for the ones who cannot leave their studies or their work or they have families, you are just like a bit more reasonable, you do it in our part-time format of 24 weeks, Tuesday and Thursday nights, and Saturday all day long. It's a big sacrifice because for 6 months you will not have any Saturdays, but it's worth it because you can change your career at the end of the day. And I don't know if you knew, but Le Wagon, we are very well known for our entrepreneurship mindsets. Every single student by the end of the bootcamp, they would have built plenty of mini apps and plenty of final projects. And we're very proud to say that with Le Wagon, we have more than 2,000 apps built by students. It's a very important thing for us to be always project-oriented, practice-oriented, to make sure that our graduates are professionals and ready for their industries. And we're very proud also that a lot of them build startups, more than 100, built by our alumni. And even more than that, we're super happy that after they come back to us to hire Le Wagon graduates as developer, project managers, or even co-founders. So perhaps tonight, some of you will find their co-founders. I wish that for you. And if you're curious about that, you can go on the quick link I put on the top of this slide. If you're curious about their companies, how much they raised, it's very important for us to have this entrepreneurship mindset. It's really part of our Le Wagon DNA. We're very proud of it. So please feel free to check it out. And for the ones who don't have the entrepreneurship spirit to build a startup, they have it to join a great tech company. We're very happy to have students all around the world in big GAFA companies, in very cool startups all around the world. It's big, big pride for us. And also, and that's the message for the students from our batch, you will be always part of our Le Wagon community. Like if you go to Europe, Asia in the near future, you'll be able to travel. You will be always welcome in all the Le Wagon schools of the world. That's also something that is super important for us, that we get to meet other people. Like before COVID, I used to receive so many people from Europe, from Japan, from Australia, coming to Rio as a tourist and actually coming to visit the school as part of the touristic trip because they wanted to know the Le Wagon team of Rio. So I wish the same for you guys. And please remember that the community will always be there for you. And if it's not presentially, it will be always on Slack, okay? Our communication platform. Please make sure that you don't leave Slack at the end of the bootcamp. This is where you will find jobs, freelance opportunities, career tips. This is forever and this is priceless. Okay? So basically, that's it. I just wanted to give you a little review of Le Wagon. If you have any questions, feel free to reach out to me. I will be there the whole event. Feel free to use the chat on the YouTube page. I will be there to answer. 9 weeks ago, 14 students started this great journey of data science with us. I'm so happy that I got to share this experience with you guys. You guys are so cute. Look at Dylan's face. Adorable. You were like all so shy and nice at the beginning, and then everybody became very wild and very fun. During these 9 weeks, we had shared plenty of happy memories. Look at these beautiful pictures I stole from our WhatsApp groups. A lot of Among Us, thanks to our Among Us captain, Mo. They were playing Among Us right before this demo. I know you guys were playing right before the demo instead of practicing. A lot of happy hours. Sorry, guys, I stole this picture too. Perhaps too many happy hours. But anyway, that's too much information for all of you. You are here tonight to see the results of these 9 weeks and 10 days. The last 10 days they've been spending coding in groups on their data science project. For the first project, I'm going to call Plot. I don't know if I'm saying it well. It's hard. You guys are ready?
Plot.
Plot. Let me stop sharing. Plot for movie amateurs.
Can everyone see my screen?
Yay.
Okay, perfect. Thank you everybody for joining today. We live in the information era. All the time we are being bombarded by content of all types. Everyone and anyone can post anything. And yes, this includes spoilers. Spoilers are the worst. No one likes to know what will happen at the end of the movie or what's going on in between. So because of this, we created a new application that can detect this. I just remember a few years ago, I really wanted to watch Avengers Endgame. But when I was scrolling through Facebook, I saw a spoiler, and watching the movie just wasn't the same. So in our new application, in Splot, we can search for reviews of any movie or show without spoilers. In this case, I would have really liked to see The Notebook. Now, I can see all of the reviews from The Notebook without spoilers. Let's try to read one without a spoiler. Great, now I can see the review without a spoiler. But what if I go all the way down and I want to see a spoiler? If someone doesn't want to watch the spoiler, well, close your eyes and shut your ears because here it goes. If you read the comment, then you can see that they are clearly telling the plot of the movie. And well, no one really wants that. So we can use the exclude spoilers feature from our app to search. Let's search from the Avengers and let's exclude the spoilers. Okay, great. Now I'm gonna go through the app and search for all of the reviews. And I don't really even have to bother about reading spoilers because each review, I'm confident that it's probably not a spoiler. But as a normal person, I don't only watch movies, I also watch shows. So let's try one of my favorite shows, Dr. House. Nice. So the way this app works, it scrapes information from the IMDb website. And talking about how this app works, for it to work, we had to train the model and train a deep learning model with more than 500,000 reviews that were labeled as spoiler or not a spoiler. For all of these reviews, we had to pre-process the text and take out numbers, the symbols. We had to lowercase it. We removed stop words, and we even converted the reviews to numbers for the computer to understand. After doing this, we trained the model and we gave deep learning model all of this data for the model to learn what makes a spoiler a spoiler. Imagine if a normal person was trying to do this, they will have to watch all the movies that exist and they will have to read all the reviews that exist in order to make this classification. So after doing this process, we can make predictions and accurately predict spoilers. Actually, from all the spoilers there are, we are able to detect 75% of them. Sorry about the other 25. So thanks a lot to the Splog team for developing this app, to Amanda, Juan, Mohammed, and well, me. Just imagine all the people that haven't watched a movie because they were spoiled. But now, thanks to Splog, the excitement, the nervousness of watching a movie without knowing what's going to happen is finally back. Thanks.
Congratulations, team. Congratulations, guys. That was awesome. I'm going to use it so much. I hate spoilers. For the next group, we're going to move to a different subject to protect the Amazon. And I'm going to call Guillaume. And who else is going to present?
Thomas,
I'm going to need to share my screen now. So, oh yeah, this second screen.
Perfect, it's working.
Are we good to go?
Good to go.
Yeah. Can everyone hear me?
Yes.
Cool. Well, good night, everyone, and welcome. Tonight, we're very proud to share with you our project, which we called Green Eye. Thomas, Vinicius, and myself, as data scientists in the making, had the feeling that the tools we had learned during this 2 months bootcamp had the potential to help solve some of the most pressing challenges of our time. Yep, no less than that. So let us go back just 4 days ago, Tuesday, December 1st, when the Brazilian National Institute for Space Research released their annual measures on deforestation, with yet another frightening set of numbers, the highest in 12 years, and result of the highly industrially oriented policies of the current Brazilian government. Compared to last year, we're talking about a loss of 11,000 square kilometers, which correspond to the equivalent of a third of Belgium. Meaning, since I started talking, we probably lost around 3 football fields of forest. For what? For industrial and often illegal activities such as mining, selective logging, and abusive agriculture. Needless to remind you that the Amazon forest is known as the lungs of our planet, capturing CO2 in the atmosphere. With that in mind, and with the growing development of image quality, greater access, and lower cost, well, satellite imagery provides a key tool for helping solve global issues such as deforestation. But it also results in a high amount of information, often difficult to handle. And that's where data science come into play. What if we could, in the blink of our green eye, get a short description of what the picture represents? This would enable the actors on the ground, governmental and non-governmental, to react quickly and appropriately according to the warning sent out by Green Eye. Also, the identification of patterns by our tool would enable proactive actions and even prevent potential damages to happen. So how can we do that? Well, first a 20-second intro to machine learning and deep learning. People often use the example of the cat and the dog pictures, in this case, a cat and a lion, where you feed your computer with a picture of both and you say, this is a cat, this is a lion. You repeat this thousands of times, and at the end, when your model is trained, you give him a picture and hopefully he tells you the right answer. The technique we used in our case is called a convolutional neural network. There are plenty of different models out there, named very gracefully, that we've listed on here on the right. So Green Eye has been trained based on a version of ResNet 50. During the past 2 weeks, this little baby has been fed with 40,000 different labeled pictures, 17 different labels, such as water, plain forest, agriculture, and 150 unique combinations of them. But I'm going to leave the screen and the floor to Thomas, who will introduce you to our results more into details.
Well, thank you very much, Guillaume. So first of all, good evening, everyone. I'm going to show you now the platform we developed for deploying our deep learning model. First, let me start loading the images. So the model can pre-process them and then analyze them to make the predictions, because it takes a really long time to do this. It's a very complex model, and it weighs like, just to get an idea, it weighs like 500 megabytes. It's like 2 movies or like a small video game. So in the meantime, I can explain you how does this work. The model takes this type of satellite images that are very complex. They have like a size of 1 kilometer by 1 kilometer, and they predict or try to predict the primary features they have. In this case, for example, we have the primary rainforest over here. We have the prediction of roads and the existence of habitational zones. For example, in this case, housing lots, or they could be, for example, houses, towns, etc. This is how basically it works. It looks simple, but it's much more complicated than that. So it looks like it's not over with the calculations. So I had beforehand a pre-trained model, so we can see what would happen here. The first result that I loaded has a correct prediction of the habitational zones here and the roads predicted. It's good to note that there are some green spots that could look like a primary rainforest, like the Amazon, but the model took care not to recognize this as such, which is a key part of our project. The second, all right, it looks like it's still running, but nonetheless we can see the result here. This is a much more interesting picture. We have the prediction of the agricultural fields here, the existence of a road predicted here, and the existence of a primary rainforest here. This example is much more important because it means a typical picture, a typical situation that happens on the rainforest, one of the most important threats to it. It's the advancement of the agricultural frontier. When we get in the future more information about those pictures, like geographical information, like longitude and latitude for each one of these spots, we could track these changes in these points of the Amazon forest. We could spot housing, agricultural fields, even illicit activities, such as mentioned before by Guillaume, when the rainforest used to be instead of these places. If we iterate all these events in the thousands or hundreds of thousands of images in the Amazon forest, we will potentially be a tremendous help for the main actors that try to, like the government, to take these decisions and stop the recession of the rainforest and its critical points, and stop accurately and in time those illicit activities. So that's what I think is the most important part of our project, the potential it has. So I would like to conclude with some words from the team of Green Eye, saying thank you very much for your attention. Thank you very much, Lewogon, for this opportunity, and thank you very much for the teachers, for your wisdom, for your knowledge, and for your assistance. Thank you very much.
Thank you, team. Wow. It's crazy to say thank you at the end when we should be the one thanking you for creating this awesome project. I wish the Brazilian government will invest in it. I wish that for you guys. Okay, talking about Brazil and the Amazon, what will be a data science bootcamp in Rio de Janeiro in Brazil without a project talking about soccer? It's soccer time now. Let's go, Felipe. Don't forget to unmute yourself.
Sorry, guys. Here.
Yes, we can hear you. Perfect. It's working.
Okay, perfect. So, guys, good evening. Our project is about soccer prediction. Brazil cannot forget about our love, that is football. So our project was done by Andres, Eva, and me, Felipe. And what was our goal with this project? Football is very popular here in Brazil, and sports betting is becoming really, really popular here in Brazil. You have a lot of influencers that are helping people to bet and to get money and etc. And so our project would like to help bettors to predict better and to bet better the results of Brazilian Soccer Championship, and also make some money too. And what was our targets of betting? We want to predict the outcome of the match, right? The number of goals that's going to occur in each match, and also the number of corners, right? So one example that we are going to predict is like the match that is going to happen tomorrow against Botafogo and Flamengo. And the output is to return the probabilities of the home win, the draw, and the away win. So one example of our output is this one. So we have in the model that Flamengo has almost 50% chances of winning, and Botafogo just 30%. What make us bet for sure in Flamengo, right? And okay, so our workflow to do this model was to gather information by scraping a website, right? Then clean and process this data scraped, train the model with this information, extract the information of the match and the teams that we want to predict, and then predict it. Our source, we extracted information from FBref. It's a huge database about sports, and you have information about like huge amount of championships around the world. And then to train our model, we use the supervised learning algorithm using historical data since 2017. So we have more than 1,200 matches. And for the targets we want to predict, we use the classification models, right? Considering that in results, we had multi-class targets, that's home win, draw, and away win. And in number of goals and corners, it's a binary target. If it's over or under one number that we define, like over one goal or under one goal in each match. So to train our model, our features were the team's performance stats of previous matches. So our predictors are information as possession, passing accuracy, shots, fouls, corners, crosses, and etc. We have a lot of features to try to have a better prediction. And so, time to predict. Let's go to our app. So here, as it takes a while to run it, I've already run some matches that will happen in this weekend. So as I said to you, the match of Botafogo against Flamengo has a probability of winning bigger for Flamengo. And also you have the probability here, for example, for the match to have one goal or more, there is a probability of 97%. That is okay. And also to have more than 9 or more corners, you have a probability of 66%. We have also the match, one other match, Fluminense versus Atlético Paranaense. Fluminense has a huge probability to win. And also we have Grêmio and Vasco da Gama. That's really sad, but Grêmio for sure is going to win. So guys, for each match, we have like predictions for the result, for the number of goals and number of corners. This one is one example of the match, one match for the weekend, Atlético Mineiro and Internacional. And that's it. Thank you so much for your attention. We invite you to bet with us for the matches of the weekend, and let's make some money.
Thank you, Felipe, so much. Congratulations, Tim. Of course, when we have such a subject, YouTube chat was going crazy over it. Congratulations, Tim.
Thank you.
You provoked some reactions for sure. Guys, I just would like to remember all of you that all of the students, they accomplished this work in only 10 days, like actually more like 9 days. So it's very impressive, okay? They were not working data science before the bootcamp. So please be impressed, because I know I am, and be proud of you guys. And for the next group, we're gonna go more into some Black Mirror subjects. We're gonna talk about emotion predictions based on speech, and I'm gonna call Dylan.
That is me. Hello. Well, I'll share my screen.
At the bottom.
Yeah. Here, can you guys see my screen?
Yeah, it's working.
Perfect. Well, hello guys. So, you know what really sucks? My last girlfriend actually broke up with me because she said I didn't understand her emotions. So I created an app to ensure this would never happen again. It's called Voice Recon. We've all been there, when you don't know what to say and you're trying to fix things, but it actually makes them harder. So, processing human emotions is a very difficult task. It is so hard that our brains process them in our subconscious in a split second, and it gives us an idea of what the other person is feeling. But many times we get the wrong impression and end up misjudging the situation. What if you had a tool to tell you what the emotion the person in front of you is actually feeling? Our solution is a deep learning application that will process audio recordings and make a prediction of the emotion that the person is expressing. We came across a dataset that we used to train our model, consisting of 2,068 audio recordings done by 24 professional actors, equally split between male and females. They were recorded saying 2 different phrases and replicating it with 6 emotions. The 2 different phrases are kids are talking by the door and dogs are sitting by the door. Have you ever seen what sound looks like? Well, we extracted features from the audio files, called spectrograms. Essentially, spectrograms, unlike my girlfriend, we can convert them into numbers and group them into arrays. Spectrograms use frequencies that can be plotted through time, and there are a few types of spectrograms used to gather the different features of the sound wave. The 3 features we used in our model are MEL spectrograms, MFCCs, and chroma. Then we gathered it all up and used a deep neural network for our prediction model. For testing purposes, we then created 3 audio recordings. The first 2 consist of me saying 2 phrases in 2 opposing emotions, happy and angry. Both recordings are spoken in English, and I'll let you hear them now. Kids are talking by the door. That was me being happy, and this is me being angry. Kids are talking by the door. So I will now quickly demonstrate how our app actually works. So we have this website, which this text just tells you how to use the app and which dataset we use, but pretty much the important thing is down here, where they tell you to drag and drop files. Well, this is prepared, so I have my files here. For example, me being angry, I'll upload it, and it gets analyzed in real time. So there, and we can see the model actually predicted me being angry. It essentially will return a table with the percentages of the different emotions. In this case, it was really precise because I really wanted to be angry. In another case, for example, me being happy, we can see it's actually recalculated, and you can see 89%. So still pretty good. Still predicts the correct emotion, so that's good. But we wanted to take it further. So we wanted to see if our model was smart enough to predict emotions correctly when we used a different language and even a different phrase than what we used to train it with. So here, basically, you have my father being sad in French.
Écoute, ça marche vraiment pas en ce moment-là. Tu es en train de merder.
Yeah, he is basically really sad, and when you drop it here, you can actually see it predicts sadness. And this was really astonishing to us, because we weren't even using the same language that we trained the model with, nor the same lines. This was insane. So yeah, there you have our app. And for potential uses for this app, well, we saw like 4 different things. Call centers, so imagine they could analyze the emotion of the person on the other side of the phone and like that optimize their customer service. Or maybe actors could use this app to get feedback on how they're performing and see if they're conveying correctly their emotions. Or detectives could also use this in good cop, bad cop situations and see if their suspect is about to break or not, if he's afraid, if he's sad, something like that. And probably what it would have been most useful for is so my girlfriend didn't dump me. Well, you can try the app for yourselves. You can either scan the QR code with your camera app or go to the website. Just make sure to upload a .wav file because we cannot work with other files. Finally, my team and I just want to thank you for listening and yeah, go ahead and try it. Thanks.
Thank you so much, Jalen. Congratulations. Wow. The chat, both on Zoom and on YouTube, has plenty of idea of application of your project. Everybody got really inspired. Okay, guys, I think now it's the end already. It's time to tell you all congratulations for real. I've never been like so proud of a batch, like all afternoon when I was revising with you all your demos, like I couldn't help to feel like how proud I was of you all. I know these 9 weeks were hard. I've seen you like sweating on the machine learning and deep learning weeks, asking me like, is it gonna get better? No, it's never gonna get better because then it's neural networks and it never stops. But please be proud of you. I know we are proud of you. The teachers are proud of you. And I think it's very important to be thanking them. Matthias, George, Marcus, Mateus, Nicola, Alexi, Hernan, Solomon, Felipe, Omar, Ricardo, Lucas, Thierry. Congratulations to all of them. I know that you were telling me every single day how they were helpful, and it's thanks to them that we're all here today. So thank you all to the teacher especially. Before we move on to the next part of the demo day, a talk with Daniel Sharam, and I think Daniel will have some ideas also of application in his job about this last project on how to predict the emotions, because he works with gamers, users, and how to predict their behaviors. Before moving to that, I just would like to invite you all to our next events. If you're curious about data science, let me check that. Next week, we'll have a workshop on lunchtime. And actually, it will be with one of our students, Guillaume, from the Green Eye project, the one about the Amazon. If you're curious about his experience and his knowledge also, he will be giving a workshop next week during lunchtime. So you're all invited if you're curious about data analytics. And if you're also curious about the experience, you can talk to him directly. I will be there too. It will be online, and I will be sending you the link on the YouTube chat to sign up. And if you're more interested about web development, well, next week I have another event for you. I have our web development bootcamp demo day, same time next week, just slightly different project. We're not gonna be analyzing anything, any data, but it will be very challenging web features. So please come if you're curious about that. And otherwise, that's it for me. Thank you so much to the whole Le Wagon team for your work over these 9 weeks. Thank you so much for the students. You have all been such awesome batch to work with. I've been loving coming to the recaps, coming to your classes. I was not understanding anything, but I was loving hearing you guys speak about it. Thank you so much. So just putting this here. So now we have a 20 minutes break before the next part of the demo day. So please stay around because we're gonna have a very interesting talk with Daniel. Vitor, are you around? Would you like to introduce Daniel for our guest to come back in 20 minutes?
Yeah.
Yeah.
Sure. All right, so in 20 minutes we start, right?
Yeah.
All right.
Okay, then see you again in 20 minutes.
All right, I'll be there.
Bye. Vitor, I think you're muted.
Hello, do you hear me?
Yeah, now it's working.
All right.
Hi, good evening, everyone.
Hello, Daniel. How are you doing today?
I am doing great.
Nice.
How about yourselves?
I'm really looking forward to talk to you. So I'll just present myself real quickly so we can start our conversation. Hello, ladies and gentlemen. My name is Victor. I am the admissions manager for Le Wagon. Some of you know me, some of you don't. I handle pre-qualification process for people that are interested in the bootcamp but still have some doubts about it. And also I was an alumni for Web Development Bootcamp. And today I am hosting this talk with Daniel Shada. Hello, Daniel.
Hi.
So, Daniel, let me introduce you about our guest today. Daniel is CIO and data scientist and machine learning software engineer and specialist for cognitive modeling researcher. He's also PhD in FGV for decision science with emphasis on cognitive science, and also he's CIO on Gaseous Games and works in the games industry, applying data science knowledge in it. So Daniel, I'm really looking forward to talk to you because today we saw really interesting demo days for our alumni in about their projects, and they're acquiring new skills in this process of getting into marketing with a lot of doubts about data science career. And I think this is a great opportunity for we to understand more about yourself. Who are you? What is your career path? So please introduce yourself and tell us about how did you become you?
Well, hold on. Do you guys is it okay if I have slides? I always have slides.
Yeah, of course, please.
Okay. I need to remember how to do this in Zoom. How do I share my
at the bottom?
Security, participants, share screen. Here we go. And I think this is it. Let me know if you guys see it. Do you see a?
Yeah, it's online.
Okay, do you see a big blue screen? And
yeah.
Actually, now, do you see a big orange screen?
Indeed.
Great, wonderful. So hi, everyone. I hope everyone made it. I would like to thank everyone at Le Wagon for the invitation to talk to you guys today. It's always an honor and a pleasure to talk to new and budding data scientists all over the world and try to impart a little bit of my experience to you guys. So let's get right to it. I usually forget to introduce myself, even though our gracious host has already done it very well. I'll try to give you guys a little bit about my career path. I'll introduce the company that I work at, Gaseous Games. I'll talk a little bit about the gaming industry, and then I'll talk a little bit about challenges, opportunities. And since every time I give this talk, people ask me about, what lessons have you learned? I always include one or two lessons, most of them unpopular, but I do them anyway. Okay. So hi, I'm Daniel. I am a software engineer by trade. I did a master's and PhD, like was mentioned. I started as a developer and a researcher at a company called Cortex Intelligence, doing mostly machine learning and natural language processing. Then I became the chief engineer at a project at the FGV Law School called Supremo em Números, doing quantitative analyses and natural language processing over judicial data for the Brazilian Supreme Court and some other of Brazil's top courts. Then I became the head of data for Reserva, the clothing company. And finally, for the past almost 3 years, I've been the CIO at Gazeus Games. So I've been in the business intelligence, law, fashion, and now gaming. But it's all been basically the same thing. It's all data, and it's all extracting things out of data and getting data to tell you things. And all right, so my specialties as when way back when I was an engineer. Now my team tells me that my job is to attend meetings and send emails. But way back when I used to be an engineer, I did a lot of machine learning, a lot of natural language processing, and I still work on strategies for complex and or massive data, which I like to call, following a book that I'll recommend at the end of this talk, data intensive processes. You guys following along with the slides? Everything okay? Can you see everything that I'm showing?
Yeah, it's perfect.
Great, good news. I'm terrible at Zoom, so. All right, so let's talk a little bit about Gazeus. Gazeus has over 10 years in the market. It started out as a web portal in a brand called Jogatina, that whose object was to bring the games that almost every Brazilian knows as live games, table games, card games, into the web space. And a few years back, about 5 or 6 years back, our CEO saw the shift in the market, and we pivoted and became a mobile company. And now we are a almost completely mobile company. And we have a worldwide presence because we are a mobile company. We have a large user base in Europe, a large user base in Asia, a large user base in the US, and obviously a large user base in Brazil. And we have a large and diversified portfolio. We are one of the top 5 mobile gaming companies in Latin America. We have over 1 million daily active users. People play our games daily. Over 1 million people play our games every day. And we have over 8 million people who play our games every month. And we have just about 450 billion new data points every single month. 450 million data points every day, which amounts to 13 billion data points every month.
It's a lot of data.
That's it's no Google, it's no Facebook, but it's fun to play with. It already poses some pretty interesting challenges. So if you ever played Buraco with your uncle or aunt on your phone, you were probably playing us. We are also one of the most popular dominoes games in the world today. So if you see the little crown on the top left there, that's us. And since we are now expanding into new games and proprietary proprietary games, games that we developed ourselves in-house, not games that have been known like Dominoes and Buraco. We're actually developing our own games to expand our portfolio. A little bit about the mobile games industry. This is a clearly completely stolen slide, but as a good scientist, I post my sources, so you can check that out at the bottom there. That's where I stole it from. So yeah, but the idea is to tell you guys how big and important the mobile gaming industry has become over the past few years. It has seen an over 65% increase since 2014. And in 2020, it has already beaten this projection. This was a projection from 2019, but the mobile gaming industry has already beaten $72 billion in revenue in 2020. The mobile and gaming industry, this one is a little bit hard to read, so I'm going to read the different bars at the names of the different bars. First in blue is the GDP, PIB in Portuguese, of Costa Rica. Second, there is the mobile gaming industry revenue. Third is all of Hollywood, all of box office revenues. Fourth, in green, is all tea sales across the world. Yellow there is all of McDonald's revenue. In pink is all of Valentine's Day spending in 2019. And last is the entire music industry. So it's a very relevant field, very relevant industry to be in. And this is the part where if we, in other circumstances, if we were live, I would ask for a show of hands, but you guys can do tell me later about your own conscience and be honest. This research says that the average person spends 23 minutes a day playing mobile games. That's 2.7 hours a week, 5.8 days a year, which amounts to 1.3 years of your lifetime. I would ask for an honest show of hands, but since most people have the camera off, I'll let that go and just assume that you guys believe this. Myself, I'm at least double this. 23 minutes a day, come on, that's too little. In terms of growth, like I said, it's over 60% growth since 2013, over 68.5 billion in 2019. And these parts are important to remember. It's a worldwide market. So every game that is published in the App Store, in the Play Store, competes with every single other game out there. That means that we compete with Angry Birds. We compete with Pokemon Go. So every single user, every single person who downloads an app, who downloads a game, has a huge set of options. Also, it's a very dynamic market. We'll see a little bit in a couple of slides. New games are launched every single day to compete with existing games. So the strategies have to change on a daily basis. And it requires a strong knowledge of the market and a strong view of all its tendencies, which becomes very important that you rely on data for that. To talk a little bit about the different business models and how does mobile gaming make money, which is kind of important. One thing is advertising, and that's how Gazeus makes most of its revenue today. It's just like television. You download a game, you download it for free, but you have to watch ads. Every once in a while, you see an ad, either partial, those ones that show up in the bottom or the top of your screen, full screen, like in between your matches, you're going to see a full screen ad, or as they're called, native, which are usually somehow they're meant to look like part of the game. There's a different type of ad, which is still an ad, but it occupies a different category for a very specific reason. That's called a rewarded video. A rewarded video is you're there sitting playing your game and suddenly game over. But watch this video and you earn a new life, or you earn new coins, or you get to keep playing. This difference is important because in this particular character of advertising, it is the user's choice to view the ad. That makes, in psychological terms, that makes a world of difference because you choose to click on the ad. So that makes the ad a lot more effective, usually. There are in-app purchases, which are the things that you buy inside the game. Buy the mega treasure chest, or buy the new sniper rifle, or buy the turbo for your car. You click on it, you go to the Google Store or the App Store. They already have your credit card number, you know they do, and you make a purchase. This is usually more effective and a lot more reliable source of income, but it's also very much harder. Most games, really good games, really popular and successful games, have about only 5% of their user base actually spending money on that game. So that means 95% of the people will never actually buy anything. And finally, there's the old model, which is you buy the game before you see it or try it. That just doesn't exist almost in mobile, except for very few and rare exceptions. But subscription model also works. Once you start your game and you're playing your game, we'll show you an option to, all right, so if you want to stop seeing ads and you want some kind of VIP bonus treatment, extra gear, better customization, fancy avatar, you subscribe, you pay a weekly or a monthly or a yearly deal, and you become that VIP user. That's a very good model for mobile gaming today. In advertising, which is what Gazeus focuses on, you have marketing campaigns, and you have marketing campaigns to bring in new users. There's the whole mechanic to it that I'll get to. You guys let me know if I'm how I'm doing on time, okay?
Perfect. We have till 8 o'clock.
Great. I'll try to not go till 8 o'clock, so you guys have plenty of time to ask all your questions.
Perfect.
We have marketing campaigns, which we advertise the game. You're sitting there scrolling Facebook. You're going to see play dominoes now, and you're going to be like, I haven't played dominoes in a while. Let's try it. You click on it, and you become our user, and you install our game. So we spend money to do advertising. So because we spend money to do advertising and to bring in new users, we don't want to spend that money just advertising to absolutely anyone. We want to be as focused as we possibly can with our advertising in order to bring in people who will actually enjoy the game. Because if we bring just anybody, most people aren't going to enjoy the game. They're like, oh man, I don't ever want to play dominoes ever. So we're spending our money uselessly. But if we focus our advertising, we can target people who will enjoy our games and who will be good users and who will have a good experience. And that's good for us, and that's good for the users. How do we focus our campaigns? Data. Once the user installs the game and starts playing, opens the app for the first time, we start measuring things. We measure how long you play the game, whether you play the game for a number of days. There are a bunch of KPIs and a bunch of things that we monitor while you are inside the game. Almost anything you do in our games, we monitor. Why? To make your experience, one of the reasons is to make your experience better. Another of the reasons is if you are a user who really enjoys our game, we can say, listen, we can say to Facebook, listen, Facebook, we're doing this marketing campaign. We're going to spend this money, but we want users who are like this one user here, because this user really enjoyed our game. And Facebook has the opportunity to really focus our campaigns. So we spend our money well, and we bring in users who will have a great experience. On the other side, we have monetization. As the game flows, we have opportunities to show ads, and we auction this space via monetization networks. Those monetization networks are also Google, Facebook, Twitter, and so on. So Google, Facebook, and Twitter, and a bunch of others make money on one side because we have to acquire users, and make money on the other side because we show ads to users. That's why they're multi-billion-dollar companies. Now the more fun part. Let's get to the technical stuff. Challenges, opportunities, and lessons. In marketing, how does a data science department help the marketing department? The marketing department spends money to attract new users. They use networks like Facebook ads, Google, Twitter, Snapchat, Instagram, Unity ads, and so on. This user is scrolling through whatever, and they're going to click and install the game. They are not going to be sent like in a website. They're not going to be sent directly to the website. There's a middleman, which is the App Store and the Play Store. So we have the user data that we feed into these ad networks to bring in the users who are most likely to enjoy our game. But once the user clicks and installs the game, we lose them in the middle ground when they go to the store instead of going to one of our links. So we need to use a partner to attribute the user to the campaign. Why is that important? Why is it important that we see, oh, this guy who installed the game came from this ad campaign? So we know that which ad campaigns are working and which ones aren't. From day to day, our marketing department evaluates the marketing campaigns that we're doing in order to say, okay, we need to shut this campaign off because we're spending money and we're not getting any good users, or we need to put more money into this campaign because we're getting great users who are really enjoying the game. All of this is based on data that we feed them. Some of the main things that marketing wants to see and that are important to them are the lifetime value and the predicted lifetime value of the users that come in through our advertising, the lifetime value and the predicted lifetime value of the users who purchase things inside our games through IAP, in-app purchases, the churn and the predicted churn of our games and of our subscribers, lookalikes, which is exactly as I mentioned, the guys who we want to feed into Facebook, the people who really enjoyed our game. So Facebook, that has all this information about a whole bunch of people, can say, okay, let's target people like this with ads for Gazeus, so they will enjoy Gazeus' games. And customer segmentation, which works about the same as everywhere else. All of these come down to one big issue, which is signals. Marketing needs early and accurate signals of our user base. For marketing to work, we must know very well to whom we are showing our ads. So as we run a campaign, we can't just show to any user. And a bad campaign will bring users who won't enjoy the game and will not play for a long time. We need to know where to show our ads so we can run our campaigns via a number of networks. And prices and the conditions of these ad campaigns fluctuate greatly. And also, there are a number of different types of marketing campaigns. Is it a campaign where we pay for every install that we get? Is it a campaign where we pay for every impression, which means every ad shown? Or is it a campaign that we call an action campaign, we can actually set certain parameters. Like, for example, we will only pay for users that install the game and play 5 games of dominoes. If they don't play 5 games of dominoes, we don't pay for them. Obviously, these campaigns are a lot more focused and effective, but they're also extremely more expensive. So all of these fluctuations and all of these things that the marketing department needs to decide becomes this nonlinear optimization problem that we need to help them with. And we need to know what to show, which means, do we show the blue ad or do we show the red ad? Do we show the ad that focuses on the competitive aspect, or do we show the ad that focuses on the social aspect?
You guys do A/B testing?
We do a lot of A/B testing. A lot of A/B testing, yes.
Can you please describe what is an A/B testing for our students?
An A/B test is when you set. Actually, we do A/B testing, but we're moving away from A/B testing towards something called the multi-armed bandit test or framework. But an A/B test means you want to see if some kind of change or you want to test something against what you have today. So what you do is you pick a sample of a random sample of your user base or of anything of your population, and you change that one thing for that random sample of your population. So let's say we want to see if the larger subscription button works better, or if the regular subscription button that we're doing is fine. Somebody has a hypothesis, which is, I think our subscription button should be larger. So we're going to pick 5% of our user base, and we're not going to show the regular subscription button. We're going to show the larger subscription button. And we're going to test this 5% with the larger subscription button, and we're going to take a sample of 5% out of the other 95%, and we're going to do a statistical test to see what works best. If the larger subscription button seems to be working better, we're going to increase the test from 5% to, let's skip ahead and say 50%. And we're going to show it to 50 and 50. And then we're going to see, is the subscription button really working? Great. If it is, we switch out our subscription button. That's how A/B testing works. And we can do that for just about anything.
Yeah, it's a really great tool that data scientists use a lot for optimizing digital products. So
definitely. A bit more advanced when you have a larger user base or a larger population size, you can do something called a multi-armed bandit, which means it's roughly like you're running several A/B tests at once, and you're always adapting to see which one is winning, and you throw more people into the one that's being most effective according to the metric that you're trying to optimize.
It's amazing how small differences can make great impact on conversion or user acquisition.
Definitely. Something that seems as innocuous as the size of a button can have a huge impact. We actually did an A/B test that went remarkably wrong. We changed because a lot of our games are card games, buraco and tranca and spades and euchre and so on. So we did a test to see if we change the size of the number on the card, the size of the K for the king, the size of the Q for the queen, and it was disastrous. People hated it. They thought, what happened to my game? That kind of thing. We started getting really bad reviews because of it. So something as small as the size of the number on the card can have a huge impact. On the monetization side, it's the same thing except the other side of the coin. people are playing our games, and we have the opportunity to show ads. Once we show ads, we go to these monetization networks, which you will recognize, called Facebook, Google, Twitter, and Unity, and so on. And we say we have this opportunity to show ads. And they have their internal mechanisms for auctioning this space. And this all happens in the span of milliseconds, okay? They auction our ad space, and we show the ad that they return to us. So we don't really go, if we have an ad space to show, we don't knock on somebody's door and say, listen, I have ads and you should buy them. We don't talk to iFood. We don't talk to Uber. We don't talk to Coca-Cola. We don't talk to McDonald's. You can tell that I was hungry as I was writing this slide, right? They're all food except for Uber. So we don't go to these. We don't go to these people. We go to Google, and Uber also goes to Google and says, listen, I want to advertise in Brazil to people of this certain specific audience. And then Google or Facebook or whoever does the matching, and we show their ads. Inside this, there is a whole aspect of it which also becomes this highly multivariate nonlinear optimization, which we'll see in a minute. We collect user data, and we have something called floors, which is, since this is an auction, Facebook and Google and so on will try to get us the best price for our ad space. So if iFood is willing to pay more than Uber, iFood wins and gets our ad space. But we can say, listen, Google, Facebook, Twitter, we have this ad space to show, but we will only take this much or higher for this particular ad space. Sometimes that threshold that we need to set will work or won't work. Sometimes even depending on the time of day. So what happens is we have all these options. So what we usually do is we try. We say, Google, we want this much. And if Google says, I have nobody willing to pay that much, we go to Facebook and say, Facebook, we want a little bit less. If Facebook says, I have nobody willing to pay that much, then we go to Twitter, Mopub. We say, Twitter, we'll take this much. And if Twitter says, no, I have nobody at this time that's willing to pay that much, we'll go to some other network and we'll say, all right, we'll take 1 cent, or we'll take whatever you can give us. All of this works within a few hundred milliseconds between the time where the opportunity to show an ad presents itself and the user actually sees the ad. So all of this is something that is eminently optimizable, let's say. And we attempt to help the monetization department in that front, in the sense that, let's see if I can go back one. How much do we ask from Google? How much do we ask from Facebook? How much do we ask from Mopub? Do we ask Google first, or do we ask Google second? Do we put somebody else on top of this list? All of these things are clearly optimizable, and they are very dynamic in the sense that they change from morning to afternoon to night, quite literally, in fact. Sometimes some network will press the button and release an entire inventory at 4 p.m. in the afternoon. So from 4 to 5 p.m. in the afternoon, they're the best performing network, and they're the highest paying network. So we stick them up way up in first place, and we get all that advertising if we're fast enough. So what are the, and that's monetization. Then there's product, which is we have to give our product department insights. What insights? Insights into how things are working. Is this feature working? What is the impact of my new social feature on my retention KPI, on my session time, on my multiplayer KPIs? Or why are my players leaving? Why aren't players staying after 3 days? So these are things that we try to explore for the product department. And the impact of certain movements. Did my subscription event convert very many players? Is my tutorial too long, or are people getting bored and leaving? These are things that we try to answer with data. So this is a very clear example. From level 1 to level 2, 90% of users pass. From level 2 to level 3, 90% of those users pass. From level 3 to level 4, only 30% of users are passing. Something's wrong with level 3. Is it too hard? Is there a bug? Why are people not getting past? These are the things that we need. These are the insights that we need to provide to our product teams so that they can improve user experience, they can improve the game, and then make the game better. So this is, as you guys can probably tell, this is a very dynamic industry. It's certainly the most dynamic industry that I have ever worked in. And we need a great deal of vision. Our decision makers need a great deal of vision. So early signals and quality signals are essential. And being able to make a decision earlier and faster can actually really make the difference between success and failure. And performance may literally change within the hour, from 1 hour to the next. So everything that we show our decision makers, the people in the marketing department, the people in the monetization department, the people in the product department, needs to be completely reliable. They need to trust everything that we tell them and every number that we show them fully and completely, every single time. So this is a quick example of something that we did. It's a quick systems analysis of a campaign for a subscription. This one game shows the campaign going up there, where you can see the spike in new subscriptions, and there's a projection for active subscriptions from an initial point, and a projection for active subscriptions in the second point, which is an action that they did that I can't quite talk about, that changed the curve, the churn curve of users coming in and users canceling their subscriptions. The second game shows the second game had a different strategy, and you can tell that the subscription projection isn't quite as impactful. In fact, it's not really very impactful at all. So these are the types of insights that we try to bring to the product department. Another example of things that we do are data engineering. We've actually done the math, and in the almost 3 years that I've been at Gazeus, our data volume has grown 1,049%. This is, as you can probably tell, this means a great deal of scalability. A lot of the scripts that had been written, we needed to rewrite because they started to buckle under the pressure and the volume of the data. One of the things that was happening is we used to store a lot of our raw data in JSON. That's a data storage format. I don't know how familiar you guys are with different data formats, but JSON is one way of storing data, and the way that we were storing the JSON became a very, very costly way of reading that data in order to transform that data into intelligence, into KPIs, into aggregate values, and so on. And the queries were becoming not only expensive, but completely inoperable. in the sense that you would press enter and you would go to lunch, and your data, you wouldn't have an answer by the time you came back. So we decided to transform our data to a different format called Parquet, which is a column-based way of storing data. So a simple change in the way that we stored our data, we obviously did a lot of planning before we did this, and we did a transition phase where we started up a huge cluster that was going to transform all this data, all this retroactive data, and so on. But once we had the data in the new format, it re-enabled a number of investigations that had become impossible. It reduced the amount of space that we needed to store that same data, and the queries became fast. I mean, fast in the sense like sub-second fast. So a simple bit of data engineering in the way that we stored our data was a game changer for a lot of the things that we were doing in the context of our growing volume of data. The first of the big lessons for the budding and new data scientists here. There's a lot of hype about data science, especially nowadays. So the first one is, this type of stuff is not really data science. Neither is this. Even though I like to work with 3 monitors and I think I should have another one, this is not data science. This is data science. Data science is the acquisition, the cleaning, the organization, the storage, the analysis, and the presentation, many times in terms of visualization of your data. A lot of the work, and I mean a lot, I mean probably usually 95% of the work comes before the analysis. It's how well you acquire, how well you're going to clean, how you're going to organize, what granularity are you going to use, how are you going to store this data? Are you going to store it in JSON, or are you going to store it in Parquet? And so on. And then if you do that 95% of the work really well, then you have the opportunity to do a really kick-ass analysis, a really impactful visualization, and so on. And then you turn to me and say, but Daniel, I'm learning all this awesome stuff, these algorithms and this super sexy AI stuff, like I didn't actually mention the reinforcement learning, but we're using reinforcement learning on our monetization problems. I really want to do all this great statistical and machine learning stuff that I'm learning. But first, you must know your data. What does know your data mean? It means really know your data. It means you need to know the provenance of that data. If an aggregate data is redistributed, its precision will very likely be affected. The distribution matters. Not everything can be considered a Gaussian. In fact, a lot of the stuff that we do, we can't take into account any model whose premise is that the data is normally distributed. Quite the opposite. A lot of our data is power law. If you try to fit a Gaussian model onto something that is power law, for example, your KPIs will probably be dangerous, misinformative. The granularity matters, which means the frequency of your collection can affect the distribution of your data. You can't compare data that is collected once every minute with data that is collected once a day. And every single extra feature also means extra complexity, processing time, and responsibility. You know the Spider-Man, with great power comes great responsibility. Yeah, in data sciences, with great degrees of freedom comes great responsibility. And cleaning. If you're using a model that's based on text, for example, if you removed your stop words, your trigram model will probably be useless. If you're filling in null values with something like 0, your average, if you take an average of that, it might be useless. So knowing these things and taking these things into account are very important. These things matter sometimes even more than what algorithm you're using. How you store your data the way the data is stored and organized, as the example showed, will affect how you can analyze it. A graph database will allow different analyses than a document database, and they will allow different analyses than a relational database, and they will allow different analyses than a time series database. So it all depends on the problem that you're trying to solve. All these tools, all these ways of doing things exist for a reason, and you should know how and when to use each one. The organization of your data matters. Is your data stored by user session? Is it stored by individual? Is it stored by device? Is it stored by app? Is it stored by country? All these things matter and will allow different analyses. And your choice of unit of measurement can further or hinder your insights. And then comes the classic, your features. There's an actual term for it, feature engineering. Understanding your data, doing histograms, checking correlation between features, between data points. Doing all of this homework can make your analysis be really highly impactful or sometimes even hurtful to your decision makers. And nowadays, way back in the day, when I started doing all of this, I used to call myself a data scientist because I did all of these things. You collect the data, you organize the data, you set up the cluster, you put the server into the air, and then you do the analysis, and then you figure out how the visualization is going to work. Nowadays, things are a lot more specialized depending on the organization that you go into. You may specialize as a machine learning engineer, and that's going to be very different from a data engineer, and that's going to be very different from a data scientist. In terms of what the person that does a little bit of all of those things is called nowadays is, as I understand it, I may be out of touch already, but as I understand it, it's called an end-to-end data scientist. And these guys are really, really valuable. The people who take the time to learn all these aspects are really rare and really, really valuable. Certainly to me. And lastly, you should be very, very careful to not become this cartoon, which is you just toss the data into an algorithm and stir and stir and stir until you get something that you want out of it. You can and you will have the power to beat your data into submission. You can and you will be able to beat your data into telling you whatever you want to hear. You should not give in to that temptation. Just to give you guys an idea of how a data science architecture works at least inside the gaming industry, is kind of like this. You have the monetization networks, you have the advertising networks, and you have the analytics networks, which feed you data and into which you yourself will feed data. There is your end user holding their cell phone there, about 1 million or a million of them a day, on quite a few days, a bit more than that, 1.5 million. And then these networks will usually, the good ones, will provide you APIs that you can rely on. You have to acquire your data. And then since each single network has a different taxonomy of data, you have to normalize. You have to make sure that the granularity is correct. You have to clean that data. And then you have to organize that data into a way that makes sense and that you can compare the different data sources. And then you have the analytics network, of all the events that everybody that's playing your game is doing. You have to pipe that into somewhere. We do it in AWS. And then you have to transform all that stuff into an aggregate that makes sense to a decision maker, like a marketing analyst, like a monetization analyst, like a product PO. And you have to create dashboards that show these KPIs in a way that makes sense to all these decision makers. And then you have a bunch of what's called ETL in between all these things. And all these things have to work. And all these things have to, every hour or every day or a few times a day. They have to run, and they have to run in a decent amount of time. They have to be performatic, and they have to be reliable. And finally is one of my lessons here. I promised them, so might as well give them to you. The first one is you should avoid being in the buzzword business. A lot of people in the data science community love being in the buzzword business. They talk about agile so and so, scrum so and so, my squad so and so, my tribe so and so. I do deep X and Y. I do deep reinforcement learning. I do deep Q learning. I do deep this and that. Understand that machine learning is a tool. The fastest Formula One car will be useless in Avenida Brasil, getting you from point A to point B. Data science is a tool. Make sure that you have the right problem for that tool. And some lessons. Reliability. Your systems should continue to function correctly in the face of adversity. And your users must be able to trust what they are seeing, always. Scalability. As it grows in volume, traffic, or complexity, there must be mechanisms so your system can deal with that growth. And maintainability. As time goes by, different humans will use and work on your systems. All of them should be able to do it productively and not curse the day you were born. Oh, that's a double slide. And these last lessons I took from this book that I always recommend in my classes and talks. It's a very good book. I don't know the author, though I admire him very much. So I highly recommend that you guys pick it up. And one last lesson. I promised that I was going to have an unpopular lesson. The unpopular lesson is, don't be afraid to use machine learning. Don't be afraid to not use machine learning. If you have a hammer, everything tends to look like a nail. Don't fall into that trap. And that's it. Thank you guys for your time.
Thank you so much, Daniel. Amazing insights and information for gaming industry and also data science in a day-to-day routine. We have some extra time left, like 10 minutes more for some questions. I myself, I have some questions because I am a data science enthusiast, and also our alumni have some questions that we would love to hear from you. All right?
Good stuff. Let's hear it.
So you've talked about a lot of things, and sometimes I think data science feels like something that is restricted for big companies, for tech corporate companies. Is there a way somehow that small businesses could start having a more data-driven culture and also using data science in its day-to-day business?
Sure. When I started at Cortex, we were 6 people, 7 people, and I was a data scientist way back then too. I think it's just a matter of how you prioritize things and what you choose to give importance to. Data science isn't easy. It's a lot of work, but one person can do it. If you have a data set that needs analysis, you just have to give that one person time to get to it. So I don't see. I think it's a matter of the people who make the decisions and who prioritize the work of the developers and the engineers to say, listen, I want this done.
All right.
But
amazing.
That tends to be harder when you're a startup and you're just trying to survive, but it can be done.
Oh, all right. So one question. I think our data scientists here that enrolled in our data science bootcamp, they started learning from Python for simple lines of code to convolutional neural networks. So we covered the whole thing. And of course, it has some levels of knowledge, but I think everyone here is able to understand everything that is said. So one more question is, what would Daniel from today, as CIO from Gazeus, would say to your younger version of yourself at the starting of your career?
I wouldn't say at the start of my career. Can I send a message to the kid that's still in school?
Yeah, of course.
Great. Linear algebra matters. It's really important. It's really, really important. Study it. Learn it more.
Why? What do you mean by linear algebra matters?
We do a lot in feature engineering, and everything that we do. A lot of what I do comes down to matrices. Comes down to a multidimensional matrix manipulation, pandas. So a lot of what the engineers do, I had to learn this after I graduated, because I started working in machine learning after I got my software engineering degree. So way back when, I thought, oh man, this linear algebra stuff, no, come on, I just want to program, leave me alone. But it turns out that having a really good foundation in linear algebra, having a really good foundation in probability and statistics, saves a lot of hard work later. So
everyone,
your statistical
study statistical inference hard and also linear algebra.
Yeah.
And for amendment for that question, in matter of fact, what would I think everyone makes mistakes in their career path. So what are the biggest, most common mistakes junior data scientists make at the beginning of their career?
I don't know that I couldn't tell you the most common mistakes that any junior data scientist does. I can tell you the mistakes that my junior data scientists make.
Yeah, perfect.
My junior data scientists make the mistake of thinking that data science is not software development. Data science was born from software development. So you need to know software development. You need to know how to document your code. You need to know modularity, abstraction. You need to learn how to optimize a query. You need to know why these concepts matter. Study algorithms. Know what a binary search tree is. These things matter when you get to the day-to-day of things. Because unless you're going to be a very, very, very specialized person in a huge company, you're probably going to have to maintain code, and you're going to have to write code that other people need to maintain. It's not going to be just, oh, I received this data set, I do this analysis, I'm done. And if you know how to write good code, and if you know how to be a member of a software development team, that'll make your life a whole lot easier.
Perfect. We can't escape from software development. So I'll open some questions for our people in the chat that are hearing us, our beautiful audience. From Matteo, our first question is, how do Gazeus use their data to become the best Domino's game in App Store?
In every single way that I mentioned. We try to use every click that our users make into a better experience. We test things. We I don't participate in that part, but we do competitive analyses of what features we should try in terms of the other things that different Domino's games are doing. There are teams of people that include data scientists and include product managers and include a whole bunch of designers.
Bunch of factors together, right?
Yeah, for sure. Yeah. It's something that's it's a priority every day, making our games better for our users.
Amazing. So data science and all the machine learning pipelines help optimize all the features, all the products, all the experience, and also revenue. We have one more question for Mohammed Indi, which is a game developer and just graduated today from the data science bootcamp. He says he wants to try to merge, congratulations, Mohammed. So he says he wants to try merge both paths together. What suggestions or career advice you could provide? And I especially would like to add, a lot of people are exiting our bootcamp and are going to market, trying to enter some selection processes to get a job. So as a person who hires engineers and data scientists and software developers, what would you say to everyone here and also Mohammed?
Okay, so for the first part of the question, I don't know how much help I can be to Mohammed. He wants to join the two paths of game development and data science. You have to either be a data scientist at a game company, or I don't know, because I know very, very little. I know almost nothing about games programming. I barely know what Unity is. So if you're trying to build and develop games, I think they're awesome and you're awesome, but I know nothing, so I can't help you. All I know is data. In the second part of the question is
the second part of the question is about hiring processes.
Yeah, I'm thinking about it. Well, first thing, you guys should send me your resumes, because I don't think we have a position open right now, but we probably will early in 2021, because my team is growing. So if you guys haven't found a home by early 2021, definitely send me your resumes. I'm always looking for talented data scientists and talented data engineers.
Yeah.
Other than that, I would say, if you do not have a programming background, if you're coming from some other undergraduate work, make your programming better. Those things that I mentioned. Learn how to make code abstraction. Learn how to make your code modular. Learn more SQL. You can always learn more SQL. Learn how to document.
The most underestimated programming language there is, right?
Yeah, the programming language concepts, abstractions, algorithms. They are the foundation of. They are still the foundation of a good data scientist. So if you don't have that, work on that. If you do already have that, I would say work on being able to show, not tell, what you're good at. The worst thing that the one thing that usually makes me just give up on a candidate very early on is they have a GitHub, and I go to the GitHub and there's nothing there. There's a really badly documented homework from 3 years ago. So if you're we have a very good opportunity. This is an industry where you guys have a very good opportunity to show how good you are. Build things, build toy problems, work on them, make them good, put them on your GitHub. People will be able to see how good you are, and that's important.
I think that's an amazing advice, and we can hear see how valuable is, because throughout all the bootcamp, all of our challenges are uploaded in GitHub. And also, I would like to finish here. We are past through our time. I would like to thank you very much, Daniel. It was my pleasure to meet you. And we are really looking for the invitation. Oh, thank you. We're really looking forward to have you as a teacher, as a professor in our data science bootcamp. So
that was you have to have Pedro give me a call.
Yeah, he definitely will. Thank you so much, Daniel. We are passing by because we're next for our next episode. We're having our data science bootcamp from São Paulo demo days. So we're seeing more pitches today. Thank you so much.
Good luck. Good luck to the presenters.
Thank you. Milene, are you here with us? Bye, Daniel.
Bye, guys.
Alô, Milene? Ana?
Olá!
Sorry. Sim. I thought Milene was hosting both, but of course, sorry, man. Let's go with Ana for São Paulo Bootcamp. Já tá em português já. Beleza.
Melhor ainda.
Então manda bala aí, Ana. Valeu. Tchau, pessoal.
Valeu, Zuc. Bom, galera, deixa eu dar um share aqui. Computer Sound não vai precisar, né? Acho que... O que tem?
Bota o Google no microfone.
Ah, mas já está conectado.
É aquele... O primeiro.
Esse? Aqui. Oi? Vê se melhorou aí. Bom, galera, vou falar bem rapidamente do Levagon, a Milene já falou, então vamos falar aqui sobre o nosso pessoal aqui de São Paulo. Bom, vamos começar falando um pouquinho de vocês, né, que é o que eu vou... os anfitriões da noite. Então, o nosso querido batch 493, quase 500, são a nossa 18ª turma aqui de São Paulo e a nossa primeira turma de Data Science. Então, vocês sempre serão lembrados como a primeira de São Paulo e uma das primeiras do mundo. Super primórdios do Levagon. E assim, primórdios, você aprendeu também. Bom, como tudo isso começou? Não sei se vocês lembram. Hoje vocês estão aqui, vocês vão virar cientistas de dados maravilhosos. Mas como começou? Lá no começo, como que a gente estava? Peraí. Windows, foi. Hoje a gente tem um espaço que está super bonito, né? Então a gente tem nossas cadeiras, o dia que a gente recebeu vocês, estava tudo bonito. Os nossos lambilambos lá em cima, nosso espaço super bonito. Então, aqui, né, o primeiro dia que a gente recebeu vocês, estava tudo arrumadinho, mas nem sempre foi assim. A gente mudou de espaço, né? Quem não sabe, o Levagon São Paulo está no novo endereço, 5 quarteirões da distância antiga, do lugar antigo. E, então, a gente passou por uma reforma. Então, tivemos algumas baguncinhas aí antes de ficar com o nosso... Pintamos a nossa parede de vermelho e tivemos uma reformulada, uma repaginada em tudo antes de receber vocês. Inclusive, tivemos que contratar professores. Então, eu e o Rafa, fizemos uma reunião com o Super Free, que está aqui com a gente, porque precisávamos muito de um data teacher extra. E o Rodrigo também, que acabou entrando depois, a gente teve essa reunião com ele, mas foi tão corrido que nem deu tempo de printar. Aqui foi antes de começar a turma, então eu e o Rafa, a gente estava na moleza ainda. E aqui, bom, vocês no primeiro dia. Então, não sei se vocês lembram disso. Todo mundo ainda, ninguém se conhecia. Todo mundo falava, nossa, que parada é essa? De data science. O Felipe vinha de camisa. Por aquilo que parece a mesma camisa, não é? É a mesma camisa que você tá hoje. Tá entregando. E aí, assim, a gente passou por muitos momentos legais, divertidos. Dentro da pandemia, como pôde, a gente conseguiu se divertir. Mas vocês também ralaram muito. Foram 9 semanas muito intensas, né? E aí, como que eu gosto muito de representar o Levagon por esse meme que um batch fez passado, Então aqui tem a primeira semana do Levagon, você é tudo fofinho, bonitinho, e agora você está todo queimado, desgraçado, porque realmente consome toda a nossa energia. E para exemplificar, a gente trouxe um ticket que foi o ticket consagrado da turma de vocês, nosso querido Joaquim, que explica bastante do espírito do Levagon. Então, assim, não sei nem por onde começar esse rolê. Que é como a gente abre um exercício, é justamente como a gente se sente. Aqui eu deixo um conselho para vocês, que a gente fala também para o pessoal de web, servia bastante para vocês, que se educar, né, estudar e aprender é uma coisa que a gente nunca termina. Então, é um conselho que a gente tem para todo mundo que é da área de tecnologia, vocês aprendem cada vez mais, programadores, cientistas de dados, que assim, você tem que estar constantemente se atualizando, porque a tecnologia é exponencial, né? Então, todo dia, então assim, que aqui seja, a gente tenha ensinado vocês a aprender muita coisa e que seja o kickoff para vocês crescerem ainda mais e dividirem essas conquistas com a gente. Queria pedir uma salva de palmas para o nosso time maravilhoso. Estava aqui. E tem uma frase que a gente usa para o pessoal de web, porque é do Linus Torvalds, o fundador do Linux, que é Talk is cheap, show me the code. Então, para vocês eu adaptei como Talk is cheap, show me the data. Então, agora vamos começar a apresentação. Antes disso, eu queria mostrar para a galera que está vendo a gente que a gente está aqui presencial. Então, deixa eu fazer uma bagunça aqui para mostrar que o nosso é mais bagunçado. Então, olha lá, a galera está todo mundo aqui. Então, eu vou chamar o pessoal vai vir aqui. E o Pedro, que está remoto, lógico. E o Bernardo também. Peraí, deixa eu... Então, vamos começar primeiro com a Super Mari. Eu vou dar o share screen de novo, Mari, aí você vem aqui no link certo. Pode vir.
Bom, boa noite. Meu nome é Maria Dayubi e eu vou apresentar o trabalho que o nosso grupo, composto por mim, Armando Rangel, Sander Blasi e Solano Japon, desenvolveu nessas últimas 2 semanas, e o nosso título de trabalho é Give Me Some Credit. O nosso roadmap para hoje à noite a gente vai se apresentar, discutir um pouco do nosso trabalho, o dataset, alguma ferramenta de visualização, o modelo que a gente escolheu, o produto final e algumas conclusões e recomendações. Nós somos um grupo de cientistas de dados que foi contratado por um pequeno banco dos Estados Unidos, e a nossa contratação se deu no meio da pandemia. Quando veio essa pandemia da Covid-19, os governos colocaram diversas medidas de lockdown nos seus países, nos seus estados, mas nós precisávamos continuar a servir nossos clientes, e o nosso banco era pequeno e não estava tão digitalizado. Com essa pandemia, essa tendência de digitalização foi bastante acentuada, e uma das coisas que o banco pretende fazer é reverter essa tendência de piora na eficiência do setor que a gente viu nesse ano. E para melhorar a eficiência, a gente vai ter que pensar em custo e receita. Receita deve ser difícil de melhorar, uma vez que esse ambiente de juros baixos deve continuar por um bom tempo, então tem que focar nos custos. E, com isso, a tendência de digitalização vai ser acentuada, e o que o nosso setor tem confirmado é que a gente entrou na pandemia de um jeito, vai sair de uma pandemia com cerca de 20% a menos de branches, de bancos nas ruas, bancos físicos. Então, é uma tendência bastante grande de digitalização. Com isso, se procura melhorar a eficiência, a produtividade e a satisfação dos clientes, acelerando o processo de resposta dos pedidos, solicitações e perguntas dos nossos clientes. E para isso tudo, a gente vai usar um algoritmo de machine learning para tentar atender todas essas demandas do nosso cliente, considerando que o banco pretende diversificar o portfólio de empréstimos, colocando um cap de no máximo 35 mil dólares por empréstimo concedido. Nossa base de dados, ela está disponível no Kaggle e ela tem 17 features e um target com 60.804 amostras. O processo de data cleaning e removal of outliers está descrito aqui, a gente não precisa entrar em detalhes, mas são coisas básicas que a gente aprendeu no curso. Como tratar null values, not available data, essas dados esquisitos, tipo esse monte de 9, a questão de valores que são semelhantes, mas escritos de forma diferente. Typos, por exemplo, para credit score, a gente tem que aqui o máximo de credit score nos Estados Unidos não dá para ver, mas são 850, e a gente tinha na nossa base de dados valores como 7.500, então claramente erros humanos. E com isso a gente tratou bastante e tirou apenas 2 outliers depois de todos esses tratamentos da base de dados. Depois a gente aprendeu que é importante fazer encoding e feature engineering. Em termos de encoding, o que a gente mais trabalhou foi a questão de buckets e aplicar label encoders. E em alguns casos a gente criou variáveis dummies, por exemplo, para tax liens, se é 0, então a gente retorna 0, se for maior ou igual a 1, retorna 1. Aqui também outras feature engineering que a gente fez. E aqui eu vou destacar a questão do purpose of the loan, que a gente agregou em algumas categorias e aplicou o one-hot encoder. A questão de loan versus income, que a gente fez a razão do valor do loan solicitado pela renda anual do cliente. Credit minus loan, que a gente fez a diferença entre o crédito disponível que a pessoa tinha junto ao banco e o empréstimo solicitado. Se fosse maior que 0, retornava 1, se não 0. E a questão de leverage, que a gente pegou quanto a pessoa estava pagando em dívida mensalmente, multiplicou por 12 e dividiu pela renda anual. Com isso, a nossa base de dados final, ela foi composta de 41.171 amostras, mas ela foi uma base desbalanceada, em que a gente tinha mais empréstimos concedidos, quase 30 mil, e menos empréstimos negados, 11 mil, mais ou menos. Então, aí a gente vai precisar fazer algum tratamento adicional. Em termos de visualização, a gente vê aqui a questão de loan versus income, né? Loan dividido pelo income, ele é mais baixo para os créditos que foram aprovados e maior para créditos rejeitados. Enquanto que leverage também tem essa característica, ela é mais baixa para créditos aprovados e maior para créditos rejeitados. Olhando por tipo de crédito, a gente vê que não tem tanta diferença nessas primeiras 4 categorias, enquanto que business loans e medical bills são um pouquinho menos, tem uma taxa menor de aprovação. Aqui é interessante também notar que crédito de curto prazo, de até 12 meses, tem uma taxa de aprovação maior do que o crédito de longo prazo, e quanto maior o seu credit score, maior a probabilidade do seu crédito ser aprovado. Com isso, a gente chega no nosso modelinho e as métricas de performance que a gente vai usar para analisar todos os modelos testados. A gente tem uma variável target que ela é binária, ela pode ser 0, no caso do empréstimo que não foi aprovado, ou 1 para o empréstimo aprovado. Então, a gente usou uma série de classification models para testar nesse dataset. Como ele é desbalanceado, a gente aplicou uma técnica de smooth, que é uma técnica de rebalanceamento para bases de dados desbalanceadas, que ela vai fazer com que o número de amostras das 2 categorias fique igual. Então, o modelo ele não vai ter mais amostras de empréstimos aprovados para treinar do que de empréstimos rejeitados. Vai equilibrar isso daí. E as performance metrics que a gente escolheu foram precision, que a gente quer estar correto com uma confiança elevada das nossas predições, para poder automatizar esse processo. E o F1, que é uma medida de accuracy, que é apropriada para datasets desbalanceados, que é o nosso caso. E a gente escolheu uma métrica de weighted entre esses dois para comparar os diversos modelos que a gente testou. Esses foram todos os modelos de classificação testados. Em todos foram aplicados Feature Selection e Grid Search para Hyperparameter Tuning. E de todos esses, o que a gente escolheu foi o Random Forest Classifier. A gente não vê que tem grandes diferenças entre esses modelos no geral. E o Random Forest é um modelo que performou bem e é simples e explicável. E aqui, comparando com um modelo totalmente randômico, que é essa linha azul, a gente vê que o Random Forest performa melhor. Comparando usando a Feature Selection que a gente aplicou, a gente vê que na matriz de correlação não se tem problemas graves de multicolinearidade, ou seja, a correlação entre as variáveis não é elevada, e a gente vê que a importância das features para explicar o modelo, a grande maioria das features foram features que foram criadas pelo grupo. Então, o Feature Engineering foi bastante bem sucedido. E aqui o nosso modelo, no teste, a gente teve essa matriz de confusão e um total de 12.353 amostras na nossa base de teste. O modelo classificou corretamente, negando empréstimos, né, para empréstimos que foram negados, 1.349. Ele classificou erroneamente, dando empréstimos para empréstimos que foram negados, 2024. Para o empréstimo que é 1, ele classificou erroneamente que é 1, ele concedeu o empréstimo, né, a pessoa humana concedeu o empréstimo, o modelo classificou erroneamente 2.551 e corretamente 6.429. Então, a gente nota que o modelo ele é muito bom em acertar as pessoas que receberam o empréstimo. E ele tem um pouquinho de falha na questão de pessoas que tiveram empréstimo negado. Quando a gente olha a precisão, a gente vê que de 100 empréstimos concedidos, o modelo classificou corretamente como empréstimos aprovados 76. E para o empréstimo negado, 35 de cada 100. Então, a gente vê que ele tem um pouquinho mais de dificuldade para entender esses empréstimos que não foram concedidos. Isso a gente atribui um pouco a biases. Biases são informações que o modelo não consegue capturar, que vêm do comportamento humano. Por exemplo, se a pessoa foi bem educada com o gerente, se o gerente estava de bom humor, se a pessoa estava cheirosa, se era homem, mulher, negro, esse tipo de característica que o modelo não consegue capturar. E tem também as biases cognitivas, que a gente chama, que acabam impactando essas decisões humanas. Entre elas, o estereotyping é bastante relevante, e tem umas outras que eu anotei aqui, mas eu vou citar, que é a questão de overconfidence. Então, o gerente acha que ele sabe mais do que de fato ele acha. A questão de anchoring, que é a pessoa fica ancorada na primeira informação que ela recebe e não consegue processar informações adicionais. Framing, que é quando a pessoa ela vê uma informação de forma diferente dependendo da forma como ela recebe essa informação. A Viability Bias, que é a pessoa dá maior importância para uma informação que ela já conhece e ela acaba dando uma maior probabilidade para esse evento se repetir no futuro. Então, são biases cognitivas que acabam impactando esse tipo de decisão também, mas não conseguem ser capturadas pelo modelo. Então, a gente falou, bom, é um modelo que dá para a gente aplicar automatização. Então, a gente decidiu 2 thresholds, olhando as curvas de precisão, tanto para os empréstimos que foram aprovados, quanto para os empréstimos que foram rejeitados. Então, nesse caso, quando a probabilidade de se conceder um empréstimo for menor que 28%, o modelo vai automaticamente negar o empréstimo. Quando a probabilidade de aprovar um empréstimo for acima de 63%, o modelo vai automaticamente aprovar esse empréstimo e tem uma taxa de precisão de 0,8, que é bastante elevada. E nesse meio, entre 28 e 63, o output do modelo vai servir para input para uma decisão humana. E a gente vê aqui, numa pesquisa que nós fizemos com os nossos clientes, eles estão muito confortáveis com essa tendência de digitalização e automatização. Então, é uma tendência que tem maior valor para eles do que o banco físico. Então, a gente está indo na direção correta. Quando a gente decidiu aplicar essa metodologia no teste, nós tínhamos 12.353 amostras, quase 9.000 foram aprovadas, 3.300 rejeitadas. Dessas 9.000, 5.800 foram automatizadas, com uma taxa de acerto de 4.595. Para os empréstimos aprovados, só 820 foram automatizados e 303 foram classificados corretamente. Então, nosso modelo foi capaz de automatizar a decisão de conceder empréstimo para 53% do total do teste. 47%, portanto, precisaram de intervenção humana e 40% dos empréstimos solicitados foram automatizados e classificados corretamente. Então, aqui a gente vai fazer uma pequena demonstração do que a gente desenvolveu no nosso...
Deve ter apagado, eu não abri. Não, ele atualizou todo. Tem problema.
Então, a gente vai pegar uma pessoa, o Felipe. Ele vai solicitar um empréstimo no valor de $35.000. O long term vai ser de curto prazo. O credit score do Felipe é muito bom, 730 ou acima. Ele está no seu trabalho atual há mais de 10 anos. Ele é uma pessoa que tem uma renda de 200 mil. De $200.000. O empréstimo vai ser para consolidação de dívida. O monthly debt payment dele é 0. Ele tem um credit history de 20 a 30. Ele não ficou inadimplente nos últimos 3 anos, não teve problema de crédito e ele tem disponível $100.000 de crédito junto ao seu banco. Então, vamos ver se o modelinho vai dar crédito para ele. Sim, seu crédito não foi aprovado. A gente vai testar agora uma outra pessoa. O Rafa Prof.
Isso foi uma luta norueguesa.
Foi. A Rafa Prof. Ele quer $6.100 apenas de empréstimo. credit score dele não é bom, está queimado no mercado.
Não estou surpreso.
Não está surpreso, né, Diego? Ele tem um trabalho, um side job, que ele trabalha desde criança há mais de 10 anos. Ele tem uma renda anual de $74 mil. O loan vai ser usado para quê, Rafa?
Comprar um carro.
Um carro.
Dívida de jogo.
Comprar um carro. O monthly debt payment dele é apenas de $1.000. Ele tem 10 anos, 11 anos de credit history. Não está devendo na praça. Não tem problema de crédito. E tem 5 mil de saldo disponível junto ao seu banco. Esses demos, eles levam em consideração aquelas probabilidades que a gente colocou nos thresholds. Aí um outro demo que a gente tinha pronto, mas não é necessário fazer, é que se o threshold estiver entre aquelas duas probabilidades, de 23 e 68, aqui a pessoa vai colocar o nome e o contato, e o modelo vai falar para ela, olha, seu crédito não foi nem aprovado nem reprovado, mas uma pessoa vai entrar em contato com você para discutir a sua situação. Aqui a gente só tem algumas conclusões e recomendações. A gente vê que é um modelinho bom, ele permite um banco que não tinha nada automatizado, veio uma Covid, fecha tudo. É um modelo que permite uma automatização de 53% das solicitações de créditos e preveu corretamente 75% delas. Nos casos em que o modelo fica naquele threshold com probabilidade de 23 a 68, essa probabilidade ela vai ser fornecida para o humano e como um input para ele tomar a sua decisão. E o que a gente vai focar nesse caso é no processo, para que pessoas que têm informações semelhantes, mesmo que atendidas por humanos diferentes, recebam um output semelhante. Então, é um foco no processo. O modelo vai continuar sendo atualizado à medida que novos empréstimos serão concedidos, e a gente gostaria que esse Loan Request Form fosse totalmente automatizado, então, para evitar erros de typos, esse tipo de coisa, então, totalmente completado online, e que o formulário fosse redesenhado para considerar essas biases que a gente não consegue pegar com essas informações que se tem. Então, incluindo perguntas como a cor, o sexo, a renda do companheiro, a escolaridade, o zip code, esse tipo de informação para tentar melhorar o modelo nesses casos que ele não performa tão bem. Muito obrigado. O grupo todo agradece pela oportunidade e estamos à disposição.
Alguém libera o vídeo aí, por favor, a apresentação do meu grupo. S'il vous plaît.
S'il vous plaît, liberar o Bernardinho.
Supostamente era pra estar aqui.
Liberar o Bernardinho ali.
Supostamente era pra estar aqui.
É um pouco de mal, o que ele sabe isso?
Search.
Não, meu time, cara. Tem que liberar ele, velho. Precisa participar desse momento histórico.
Ali tá tudo bem, isso. Tenta ver o PowerPoint.
Libera! Libera!
Aqui?
Aí foi. Tenta ver o PowerPoint.
O PowerPoint
Porque ele tá com a.
É que eu acho que
esse os comentários.
Aí?
Ah, não, tá certo.
Foi.
Deixa eu mal.
Ah, que tá a versão de apresentação.
Boa noite a todos. Meu nome é Bruno Madureira, juntamente com meus colegas Bernardo Caiado, Joaquim Oliveira e Rofer Rendon. Fazemos parte do batch 493 Alevagon de Data Science e são 8h35 dessa noite. A grande pergunta é: qual de vocês ainda estão aí e quem não vai tomar uma cervejinha na sequência? Porque se a sua resposta é que não vai, provavelmente você vai ficar na sua casa tentando procurar algo para assistir. E pensando nisso, nós fizemos a seguinte pergunta: quanto tempo da sua vida será que você gasta assistindo programas de TV? E a resposta é 78 mil horas, segundo a estimativa de um estudo britânico. Isso equivale a mais ou menos 9 anos da sua vida assistindo programas de TV. Dentre eles, são mais de 3.600 filmes, 31 mil episódios de TV, 11 mil séries. E a segunda pergunta que não quer calar é: quanto tempo da sua vida será que você gasta tentando decidir o que assistir? Esse mesmo estudo nos mostra que, na verdade, são mais de 2.900 horas, o que é equivalente a 120 dias, ou 4 meses, 1/3 de um ano, apenas tentando escolher o que é que você vai assistir. E muito embora diversos desses sistemas e programas de streaming nos dê recomendações, elas são, de certa forma, limitadas ao conteúdo da plataforma, e alguns sites que tentam dar notas aos filmes, eles também não fazem nada que seja para você. E isso é um tanto quanto chato, né? Mas e se eu te contasse que seria possível você assistir aos principais filmes do mundo recomendados para você?
Seria muito legal.
E pensando nisso é que criamos o Rogue, uma aplicação baseada em algoritmos de machine learning que busca fazer recomendações para cada pessoa com base na similaridade entre usuários. Então, quando você entra no Netflix e você sabe que pessoas assistiram a tais filmes e que combinam com você, é esse tipo de algoritmo que falamos aqui. E o segundo deles é com base nos filmes em que você gostou, que é o Content-Based Similarity. E para isso, meu colega Joaquim vai explicar um pouco melhor para vocês a mágica por trás do sistema.
Boa noite, pessoal. Obrigado, Bruno. Eu vou explicar um pouco da matemática que acontece aí por trás da mágica. Primeiro, vamos explicar um pouco do modelo que é de recomendação baseado em gosto. Como que a gente descobre quais são as pessoas que têm um gosto similar ao seu? A gente utiliza uma técnica de machine learning que se chama filtro colaborativo. Então, vou dar um exemplo muito fácil aqui para vocês, muito simples, né? Imagine que nós temos 4 usuários que expressaram a preferência deles, dando notas para alguns filmes. Agora, imagine que a gente tem um 5º usuário. Então, em qual desses 4 usuários esse 5º usuário se assemelha? A gente pode notar que existem 3 padrões aí. Quando não tem similaridade nenhuma, por exemplo, com o usuário 1, pois eles não viram os mesmos filmes. Quando tem uma similaridade baixa, por exemplo, com o usuário 2, pois eles deram notas opostas. E quando tem uma similaridade alta, como o usuário 3 e o 4, que eles deram notas bem paralelas àquela do usuário 5. Isso é muito bom, dá para entender esse conceito, mas a matemática precisa de mensurar isso. Qual é o número dessa similaridade? E aí a gente consegue utilizar uma outra técnica que se chama similaridade de Pearson. Então, um exemplo muito fácil de entender é, imagine que você tem dois usuários, o usuário A e o usuário B, e você quer descobrir se o usuário C ele está mais próximo, tem um gosto mais próximo do A ou do B. A gente poderia imaginar simplesmente uma distância euclidiana entre esses vetores, mas não tem uma distinção tão clara. Então, a gente lança a mão da similaridade de Pearson, que é relativa ao ângulo entre esses vetores. Então, imagine assim agora que a gente tem aí somente, a gente tem 2 filmes e 3 usuários, imagine que a gente fez isso para 160 mil usuários e 60 mil filmes. Então, essa é a parte do primeiro modelo, recomendar filmes de acordo com o seu gosto, certo? Vamos passar para um próximo modelo. O próximo modelo, ele vai te recomendar filmes de acordo com um filme específico, baseado no conteúdo daquele filme, né? E para isso, você tem que fazer, assim como nós tínhamos no modelo anterior, usuários e filmes, aqui a gente tem vários filmes e várias características desses filmes, certo? Só que essas características de filmes, como diretores, atores, gêneros e os tags daqueles filmes, estão em palavras. Então, a gente precisa usar uma outra artimanha do Machine Learning, que é o NLP, e, para isso, transformar palavras em números e poder fazer toda essa matemática e descobrir essas similaridades. Mas chega de matemática, pegue suas pipocas e vamos testar o nosso modelo. Vamos começar aqui. Cadê o negócio aqui do... É isso. ESC. Ajuda nesse Windows aqui que eu não sei usar esse negócio muito bem.
Tem um lote, tá?
Pô, cadê aqueles 4 dedos do Mac que você faz assim, abre tudo e não tem no Windows, cara?
Eu também não sei, não.
Vamos embora aqui.
Ah, monstro. Muito bem.
Mas você precisa sair daqui. Aqui tá aparecendo.
Tá aparecendo aí já?
A gente consegue ver o...
Aí, tá. Nossa, a nota até manteve. Tá? Então, posso continuar? Então, beleza. Então, imagine aqui, nós temos aqui na nossa primeira parte, a gente pode capturar, fazer as recomendações de acordo com o rating e de acordo com o conteúdo. Vamos começar pelo rating aqui. Primeiro, vamos capturar os seus gostos, certo? Então, vamos pegar aqui, a gente já pré-selecionou alguns filmes de ação, para não ter que preencher esse formulário. Temos aí o Deadpool, Transformers, o Matrix, e tiramos alguns filmes mais de criança, por exemplo, Chicken Run e o Cars, né? Falamos que a gente não gostou muito deles. Vamos ver, então, o que o nosso modelo nos recomenda. Ele vai procurar, então, outros usuários que votaram em filmes semelhantes com os seus, ver os filmes que você não viu e recomendar. E a gente tem aí bastante coisa interessante, né? O segundo tipo de modelo é quando eu vou pegar um exemplo específico. Então, vamos para a parte do conteúdo. Vamos escolher um filme aqui, por exemplo, o Fury. E agora a gente pode escolher como a gente quer sortear esses filmes mais similares, por popularidade ou por voto média, a nota média que ele tirou, certo? Vamos, por exemplo, por popularidade. E vamos ver que filmes eles nos recomendam. Ó, bastante interessante. Bastante filmes de ação, de guerra, por exemplo, Capitão América, tem a ver com a Segunda Guerra também. O Inglourious Basterds. E a gente pode mostrar aqui também, através do Vote Average. E temos aqui outros filmes também bem parecidos com aquele primeiro. Bom, pessoal, por fim, vale a pena lembrar que todos esses modelos nossos, eles são baseados em modelos de não supervisionados. Isso quer dizer que a gente não tem um guia que vai levando a nossa máquina, o nosso computador a achar uma certa resposta. E isso é o Rogue. Assim que vocês puderem, podem entrar aqui nesse link, está disponível esse aplicativo para vocês. Muito obrigado.
Aê! É nóis!
Caramba, como é que eu vou botar o primeiro? Olá, boa noite, tudo bem? Hoje a gente vai apresentar um projeto de conclusão das nossas 2 últimas semanas aqui no Levagon. Foi um projeto de Data Science e Machine Learning aplicado à área de recursos humanos, e que é mais conhecido hoje em dia como People Analytics. E esse projeto ele visa identificar quem são as pessoas que têm o maior potencial de deixar a empresa nos próximos meses. Antes de começar, eu queria primeiro agradecer aos meus companheiros desse trabalho, a Venha, Candela, Justin Chafro, e ao querido Pedro Mesquita, que está lá em Portugal. Nesse momento deve ser quase 1h da manhã. Ele está até aí com a gente. Valeu, Pedro, muito obrigado. Muito obrigado a vocês meninos também. Vamos continuar. Como eu disse, qual que é o problema de perder funcionários? O problema é que isso custa muito caro para as empresas. Não só porque a fuga de talento é um problema que tem que ficar retreinando essas pessoas, mas porque, segundo a Forbes, o custo de perder esse funcionário varia de 40% para funcionários mais de skills técnicas e até 200% em alguns casos de skills executivas, como CEOs e outras áreas, do salário anual, dizendo isso, ou seja, um custo muito alto. E para resolver esse problema, a gente traz uma solução de People Analytics, onde a gente usa um algoritmo de Machine Learning para prever quem são essas pessoas que têm propensão a sair do trabalho, e a gente classifica essas pessoas entre attrition e não attrition, sendo pessoas com atrito ou não atrito, e para ficar mais fácil do modelo entender, a gente vai ver mais para frente, eles vão ser classificados como 0 para pessoas que não têm atrito e 1 para pessoas que têm atrito. Com isso, a gente espera que a empresa economize dezenas de milhares de dólares e, além disso, que ela possa atuar quando ela identifica um funcionário que tem propensão a sair, fazendo com que ele se sinta mais confortável para ficar a partir de estratégias de permanecer essas pessoas, para fazer permanecer essas pessoas na empresa, ou seja, tornando a empresa um lugar melhor melhor ambiente para as pessoas trabalharem. Esse aqui é o nosso dataset, ele foi um dataset retirado do Kaggle também, ele é um dataset postado pela IBM, mas ele não é da IBM, né? Ele não é específico para a IBM, como a gente pode ver nos dados, durante nossa análise, foi um dataset retirado de uma empresa de uma indústria farmacêutica. Tem a ver com Research and Development, com área técnica de laboratório, além de outras coisas mais gerenciais como RH e Sales Development também. É um dataset que tem 35 variáveis e um pouco mais de 2.000 funcionários cadastrados nesse dataset. Antes de mais nada, a gente queria falar um pouquinho como é que esses dados foram pensados, né? No começo a gente pegou esses dados e fez uma análise deles, linkando cada uma das variáveis com a nossa variável target, que é o atrito ou não atrito. E aí eu vou falar só primeiro desse gráfico, porque a gente tem uma porção deles, quem tiver interesse depois a gente pode disponibilizar a análise do trabalho. E basicamente a gente consegue ver que o amarelo são as pessoas que não têm atrito, e o azul são as pessoas que não têm atrito. A gente vê que a proporção de atrito existe mais significativa nas áreas de vendas, de recursos humanos e de técnico de laboratório, logo no começo. Enfim, como a gente tem dezenas de gráficos a esse respeito, eu não vou passar por muitos deles para não ficar muito cansativo essa apresentação, mas esse aqui é um importante. Esse aqui é a nossa variável target, como eu disse, é atrito e não atrito. E a gente pode ver que ele é um dataset desbalanceado, ou seja, se a gente for passar um modelo de machine learning em cima dele, ele pode ser um modelo muito preguiçoso, porque assim, como ele tem muito mais pessoas que não têm atrito do que pessoas que têm atrito, se ele chutasse que todas as pessoas não têm atrito, ele seria um modelo que tem uma boa performance. Por isso é necessário que a gente aplique uma técnica de balanceamento desses dados. Ela é conhecida como, e uma das mais robustas hoje em dia, é conhecida como SMOT. A gente aplicou essa técnica e no final nós tivemos, nesse dataset de treino, 687 dados para cada uma das classes. Depois de fazer esse processo de smoothing, a gente também pensou em feature engineering. Essa parte é bem legal porque se a gente vai falar sobre uma área de várias áreas dentro do machine learning, especificamente quando se trata de pessoas, a gente tem que levar em consideração que as variáveis são uma representação da realidade, que elas não definem a realidade como um todo. E esse dataset que a gente tinha, na verdade, ele era informações gerenciais. Então, como é que a gente vai conseguir prever se a pessoa tem vontade de deixar a empresa a partir de informações, tipo, quantos anos ela trabalha na empresa, quem é o gestor dela? São variáveis muito gerenciais. Então, a gente tentou pegar essas variáveis e transformar isso de uma maneira mais humanizada, com uma técnica de feature engineering. Depois a gente também aplicou um pre-processing. Vou falar um pouquinho melhor dessas variáveis de feature engineering. Primeiro, a gente aplicou várias variáveis para fazer feature engineering, mas as 4 mais importantes foi uma mescla de renda anual com o nível de hierarquia dessa pessoa no trabalho, onde a gente fazia uma análise, por exemplo, se essa pessoa tinha um salário menor do que 50% das pessoas que trabalham naquele departamento com aquele nível de hierarquia. Então, se a pessoa recebe menos que seus companheiros, ela tende a ser uma pessoa que tem mais atrito. Da mesma forma, a gente também fez um link de renda anual com o total de anos trabalhados, também foi uma variável importante, ou seja, a gente fez renda por ano trabalhado, marcando uma variável numérica. A gente também criou uma monthly income per age, ou seja, pela idade total da pessoa, que embora seja muito parecido com essa número 2, ela não vocês não estão vendo o número aqui em cima, mas eu acho que dá para ver no slide, né? Ela é muito parecida com a número 2, a gente fez uma técnica de autocorrelação e percebeu que o modelo não interpretava como autocorrelacionada e que ele classificava de uma maneira que a performance do modelo pudesse, de fato, fosse melhor. E, por fim, a última que fez muita diferença no nosso modelo foi linkar o education field, o campo de estudo da pessoa, com a área de trabalho dela. Então, se a pessoa trabalhar na mesma área dela, a gente interpreta que a pessoa está mais satisfeita com o trabalho do que se ela trabalhar numa área diferente do que ela estudou. Depois a gente aplicou duas técnicas de scaling. Uma delas é o robust scaling. Ela lida melhor com dados que são outliers. Outliers são dados que estão muito fora do padrão comum daquela variável. Então, por exemplo, se a média e a mediana, o range de ganho anual de uma pessoa vai de 2 a 10 mil e tem um funcionário que ganha 45 mil, essa pessoa é um outlier. E isso pode ser isso deixa a performance do modelo um pouco mais complicada, um pouco mais baixa. Depois, para outras variáveis que não tinham outliers, a gente aplicou uma técnica de standard scaling. Deixa eu tirar isso aqui, né? Acho que fica um pouco mais fácil de respirar. A gente aplicou uma técnica de standard scaling, que é uma técnica também de ajustar as grandezas de variáveis. Então, por exemplo, se a gente tem a variável salário, que, como eu disse, vai de 2 mil até 30 mil dólares, e uma outra variável que é a distância do trabalho, que é de 2 a 30, esses números em ordem de grandeza, as variáveis que têm até 30 mil dólares, ela pode ter uma performance, ela pode puxar esse modelo mais para o lado dela, falando assim, eu tenho mais relevância, quando na verdade não é o caso. Então, a gente aplicou esse scaling para que elas tenham todas a mesma escala, em termos de distância, num gráfico 2D, por exemplo. Aqui a gente também tem mais um gráfico onde a gente analisa depois da Feature Engineering qual foi o nível de atrito ou não para essas variáveis que foram criadas. Também não vou entrar exaustivamente nesses assuntos, quem quiser pode ver depois. Enfim, até o momento que a gente fez no dataset foi fazer o data cleaning, depois a gente fez um Feature Engineering, como eu disse, fez o scaling dos dados, e agora a gente vai fazer o treinamento dos modelos, determinar quais são os modelos que a gente vai seguir e fazer o treinamento desses modelos. Como eu disse... Nossa, saiu errado. Como eu disse, esse é um problema de classificação, ou seja, classificação binária especificamente, e os modelos mais importantes para esse tipo de problema foram utilizados para fazer o treinamento e a avaliação desses dados, mas 3 deles foram os principais, sendo eles de Logistic Regression, Random Forest e XGBoost. E no final, eu tentei fazer um stacking, tentamos fazer um stacking desses modelos, que através de um algoritmo chamado Voting Classifier. Então, se o Logistic Regression e o Random Forest classifica esse dado como 1 e o XGBoost classifica como 0, ele fala assim, 2 modelos votaram 1, então eu confio mais no 1, vou chutar 1. Esses foram os dados dos nossos 3 principais modelos. Eu não vou entrar em cada uma dessas métricas agora. E aí, esse aqui é o nosso último modelo. Quando a gente chegou no nosso último modelo, a gente falou assim, bom, tudo bem, a gente tem um monte de métrica, e qual que é a nossa métrica que a gente vai utilizar? E a gente falou, bom, voltamos para o início do nosso problema. O que a gente quer saber? Qual que é a principal dor que o nosso problema tenta resolver? A gente quer prever corretamente as pessoas que têm atrito. Ou seja, nós estamos muito mais interessados em saber que a pessoa que tem atrito e que o modelo foi capaz de prevê-la do que pessoas que o modelo preveu como atrito, que na verdade não são atrito. Por que isso? A gente interpreta que as pessoas que foram classificadas erroneamente como tendo atrito, quando elas não são atritos, elas vão ser mimadas pela empresa. O que tem de mal de ser mimado pela empresa? Nada. Na verdade, quando a empresa também se predispõe a fazer um ambiente melhor para que esses funcionários possam trabalhar, ela acaba criando um ambiente melhor para todos os funcionários. Então, para nós, o nosso custo de perder funcionários, portanto, prevê-los corretamente, é muito mais importante. Por isso, a gente utilizou a métrica Recall. E utilizando essa métrica, e no modelo que a gente fez o stacking, que é esse modelo de voto, né, o Voting Classifier, nós tivemos um recall de 70% e um F score de 42%. E aí nós vemos que apenas 12 funcionários foram classificados erroneamente como não atrito, quando na verdade eles tinham atrito, e mais funcionários foram classificados como não tendo atrito, quando na verdade eles não tinham atrito. Mas, como eu disse, essa não é uma métrica que a gente estava se importando muito, o nosso principal era em relação ao 12 aqui embaixo. Aqui a gente tem uma parte de feature importance, depois que a gente rodou o modelo, a gente viu que o custo desse funcionário mensal para a empresa era uma variável que tinha muita influência. Além disso, algumas outras variáveis que a gente criou também estão logo aí em cima, como renda mensal pelo total de anos trabalhados, por idade, enfim, essas variáveis, depois vocês também podem dar uma olhada se vocês quiserem, eu posso disponibilizar esses dados. Por fim, a gente tinha esse modelo previsto, que a gente tinha considerado como uma boa métrica, uma boa performance. A gente tinha que entregar isso para a empresa que precisava prever quem eram os funcionários que estavam saindo. Idealmente, essa parte seria aplicada dentro do sistema de RH da empresa. Então, assim, a pessoa teria um sistema que era alimentado automaticamente a partir de outras métricas, outros resultados, outros databases, e quando uma pessoa tivesse sido classificada como atrito, subiria um flag, a pessoa receberia um e-mail ou algum outro tipo de interface, onde ela ficaria sabendo que esse funcionário é atrito e, portanto, ela deveria tomar alguma medida para tentar fazer com que ele não saísse. Nesse caso, a gente vai criar um pequeno website, onde a gente pode subir, deixa eu carregar ele aqui. Esse é o nosso grande website, a galera de dev pira, né, no nosso design. Bom, aqui é, obviamente, a parte da Best Pharma. Eles fazem o download de um arquivo a partir das informações do database deles e sobe aqui. A gente vai subir esse dataset agora. Aí ele passa pelo modelo. E ele fala que os seguintes empregados podem deixar a Best Pharma nos próximos meses. Aí tem a lista dos empregados com o employee ID deles, a idade, algumas informações um pouco mais gerenciadas para que a pessoa da RH possa ter um panorama um pouquinho mais completo a partir do momento que ela veja isso. Basicamente, então, a gente fez... Basicamente, a gente novamente fala, a gente fez nesse programa, a gente fez um data cleaning, limpou todos os dados, fez um feature engineering, depois a gente escalou os dados para que a gente não tivesse um modelo que tivesse pouca performance, praticamos em diversos modelos, escolhemos o modelo principal de acordo com a métrica que a gente considera a melhor métrica para esse momento, fizemos o deploy do modelo para que as pessoas que pudessem utilizá-lo de maneira automatizada e que pudesse, por fim, ter o resultado que era a previsão. Então é isso. Vamos fazer as empresas um lugar melhor para trabalhar com a ajuda de inteligência artificial. E muito obrigado por ter acompanhado a gente essa noite, enfim, durante todas as 9 semanas também. Muito obrigado, queria agradecer aos meus companheiros, a toda a Levagon. Muito obrigado, é isso aí, gente.
Gente, é isso aí. Espero que vocês tenham gostado. Nossos grupos aí ralaram pra caramba para montar isso daí para vocês. E agora, bora sextou, né? Para quem tá em casa, muito obrigada por acompanhar a gente. Cadê o Pedro? Eu queria dar um tchauzinho pro Pedro, o Bernardo, galera que tá aí. Vamos.
Aqui.
fechar o Screen Gallery. E... Gente, eu sou muito ruim de mexer no Windows. Eu não sei mexer no Windows. Aqui, ó, consegui colocar algumas galinhas. E... Valeu, gente. Muito obrigada. Bom fim de semana. Pedro vai dormir, tá muito tarde aí. Parabéns, cientistas de dados. Primeiras turmas do Levagum Brasil, América Latina. E é isso aí, gente. Valeu, obrigada.